Numbers are not merely tools. They are the unseen grid overlaid onto reality, allowing us to parse, predict, and manipulate the world around us. We often take them for granted, yet try to imagine a moment without them, and the very fabric of our understanding begins to unravel. This isn't just about counting apples or calculating a bill. It's about the innate, almost subconscious awareness of more or less, a fundamental perception that precedes formal enumeration. From the earliest dawn of human consciousness, and indeed within the animal kingdom, there exists a capacity for what scientists call numerosity, a gut feeling for quantity that doesn't rely on symbols or words. We inherently know a pack of wolves is distinct from a solitary predator, or a bountiful harvest from a meager one, without needing to assign a specific digit. If numbers vanished, our daily lives would transform into a ceaseless act of qualitative comparison. Bartering would involve meticulously matching piles of goods, not by a fixed numerical value, but by an intuitive sense of equivalent worth. Time itself would revert to cyclical observations, the sun's arc, the moon's phases, the ebb and flow of tides, or the return of migrating birds. There would be no shared chronology, no scheduled appointments, only an understanding born from repeated patterns. Construction projects would rely solely on proportionality and visual symmetry, fitting pieces together based on direct comparison rather than precise measurements from blueprints. A wall would be built as tall as a man, and a roof wide enough to cover, completely devoid of meters or feet, leaving no room for standardized, replicable designs across distances or builders. While our innate numerosity allows for approximate judgments, like discerning between 10 pebbles and 20, this capacity quickly falters as quantities become larger and closer together. This phenomenon, known as Weber's law in the context of numerical cognition, means we struggle to differentiate between, say, 100 and 105 objects without explicit counting. Human language plays a pivotal role in extending this basic numerical sense. Cultures that possess limited number words, for example, often struggle with precise quantification beyond 1, 2, and many, showcasing how linguistic scaffolding elevates our raw perception into sophisticated numerical understanding. Without the specific linguistic constructs for 3, 4, or 1,000, our brains might never develop the neural pathways for abstract, exact numerical representation. This isn't just a matter of labeling, it fundamentally alters how we perceive and interact with distinct quantities, making anything beyond rough estimation an insurmountable cognitive hurdle. Without numbers, the bedrock of all advanced scientific and technological progress instantly crumbles. Physics, predicated on precise measurements and mathematical equations describing forces, motion, and energy, would cease to exist beyond anecdotal observations. Engineering, architecture, and even basic resource management would regress to an intuitive trial-and-error state, devoid of the complex calculations required for structural integrity or optimized allocation. Imagine a world where there are no units of temperature, no atomic weights, no exact distances to navigate by. There would be no GPS, no sophisticated medicine with precise dosages, and certainly no understanding of the cosmos beyond what we could visually perceive. Concepts like zero or infinity, fundamental to higher mathematics and theoretical physics, would remain forever elusive, trapping humanity in a qualitative existence incapable of grasping the abstract extremes of non-existence or endlessness. Numbers are far more than mere counting tools. They are the unseen architects of our reality, allowing us to move beyond simple perception to profound understanding. They provide the framework for abstract thought, enabling us to compare, predict, and manipulate phenomena with an accuracy that would be impossible otherwise. Our capacity for quantification underpins everything from the economic systems that govern global trade to the intricate code that powers digital communication. Without them, our world would be one of perpetual ambiguity, where every judgment is relative and every observation remains unconnected to a larger, quantifiable pattern. The elegance of mathematical structures, from prime numbers to fractals, reveals a hidden order that numbers not only describe, but also, in a very real sense, help us to construct within our minds, transforming raw perception into meaningful, actionable knowledge.